Hello everyone, I welcome all of you once again to the series of speed time distance. In this video we are going to talk about circular track. Circular track, which is a kind of a loop, closed loop, which does not have any end point like people are running there, right? So to understand or to handle these type of questions, you need to understand the type of question. The concept which we are going to use here is relative speed. Relative speed. Okay, so let's see what is relative speed. We have discussed relative speed before. Let's have a quick revision of that. So relative speed is speed of one object with respect to other object. Okay, when they are moving in the same direction, then we say relative speed will be x minus y. When they are moving in the opposite direction, then the relative speed is x plus y. Right? Fine. So let's see the type of question which we encounter in this type of question. This type, circular track. Okay, so we have a question which says John and Michelle are racing around a circular track with a length of 700 meters. So the circumference of this circular track is 700 meters. John can run with a speed of 40 meters per second, whereas Michelle, it is 30 meters per second. Fine, no problem. Okay. Then what do we need to find out? If they both start at the same point and run in the same direction, how long will it take for take John to overtake Michelle for the first time? Now understand, if it is a circular track, when they are starting from a common point, John and Michelle, both of them, right? How can John overtake Michelle? Because John is going to complete the circle before Michelle, right? And Michelle will be still, Michelle is slower, right? Michelle will still be somewhere on the way on the track, yeah, in some position on the track, right? At some place on the track, correct? Yeah. So how will John overtake Michelle? So in such case, we have to assume that John is not stopping at this point. When they start, it's not stopping after completion of one lap. John is continuing. Okay, only in that case John can overtake Michelle. Okay, so when you see circular track and if the faster one is overtaking the slower one, you need to understand that he is keep running. Yeah, he's completing the first lap and then continuing the second lap, third lap, that way. Okay, so in which case John can overtake Michelle. Now understand this. Suppose, let's say, let me take this blue color for John. Okay, let's take red color for John. Okay, John red color. Now suppose if John run on the circular track and complete the race here, complete first lap, and I'll use the white one for Michelle. Michelle is still on the way, not completed. Why? Because Michelle is slower. Now Michelle is here. By the time Michelle is here, John continue running, and John also somewhere on the track meet Michelle by the time Michelle is here, let's say. Okay, yeah, if you look at this carefully, John is completing one lap and covering the extra distance in the second lap. The second lap distance covered by John is equal to the distance covered by Michelle. Yeah, in a nutshell, what I'm trying to say is, in circular track, if the faster one overtake the slower one, keep in mind, in a circular track, if the faster one overtake the slower, okay, is possible, okay, or let me say then the faster one has definitely covered one lap extra, okay, extra compared to the slower one. Did you understand this? Think about it. Think about it. Let me draw this diagram once again for you. Think about it. If I say there is a circular track, okay, this is a circular track. Okay, now if John starts from here and Michelle starts at the same point here, okay, running in the same direction, John is faster, so John is going to complete one lap. In the meantime, Michelle is slower, so must have not completed the track, so complete circle, one lap, so somewhere in between. Okay, now John keep continuing from here and definitely going to meet Michelle. Okay, by the time Michelle is also covering some extra distance, right? Going to meet Michelle somewhere in between, right? Now look at this red line. From here, if you see this one lap plus this extra distance in the second lap. Now distance in the second lap is equal to Michelle's first Michelle distance covered in the first lap itself, right? So if you get to see, John is covering, you know, this entire circle plus this part. Let's say Michelle covered x meter. So John covered this entire lap plus x meter, where Michelle covered only x meter. Only in this case they will be able to meet. Only meet means once they meet, then only John will overtake, right? So when you say the faster one will meet the slower one, or they meet together, or the faster one will overtake the slower one, all these things are same mathematically. Okay, so you will see that the John is taking John covered the entire one lap plus x, whereas Michelle covered only x. So this L, the lap, the one circle, you know, when you come to the, he comes to the starting point, you know, from here we are he's covering the extra x meters, whereas Michelle has covered only x meters. Only in this case they will meet. So remember, when in the circular track, if the faster one overtakes the slower one, then the faster one has covered one lap extra compared to the slower one, right? So this you should write in a note or as a tip, whatever you want to write this as, but this is important statement. Okay, now how will I use this statement to solve the question? Now when they go in the same direction and question said find the time, if both of them are, how long will it take? That means we need to find out the time. Okay, so the time taken here will be equal to distance upon speed. Now when we are talking about two people running, like two objects are moving, two people running, so we have to apply relative speed. When we look at the relative speed, we also have to look at the relative distance, right? So if we look at relative speed with respect to John, with respect to Michelle, has to cover one lap extra. Yeah, if you look at the distance, John has covered L plus X, where Michelle covered only X. So relatively John has to cover one lap extra. So as a distance here we will consider only the length of this track. Okay, lap means one complete circle, circumference, okay, length of this track, which is 700, and relative distance here, relative speed will be when they are moving in the same direction, relative speed will be difference, correct? Relative speed will be difference, moving the same direction, relative speed will be x minus y, difference. So distance is 700 and here difference is what? 10. So answer will be what? They will meet after 70 seconds. Okay, so calculation is fine. Calculation, I'm sure you will be able to do it. That's pretty easy. But this concept, are you okay with this concept? Yeah, the faster one has to, run fast and complete one circle and then cover extra distance, which is equal to distance covered by the slower one. The faster one will cover the first entire one circle, the one lap, plus some extra distance. That distance supposed to be equal to distance covered by the slower one. Only in that case they will meet. Yeah, when they are running in the same direction. Okay, and overtake is definitely possible only when they are running in the same direction. How will overtake happen when they are running in the opposite direction? When they are running in the opposite direction, it is called they cross each other. Okay, overtake will happen only in the case of same direction. So you don't have to mention that. It should be obvious. Okay. Now same case if I see, if both starts at the same point and run in the opposite direction, then what will happen? Okay, run in the opposite direction. That should be pretty simple and easy for you. That should be pretty simple and easy for you. If they are running in the opposite direction, yeah, they are running in the opposite direction, then if one start, this is a starting point, let's say one start from in this direction, the other start in this direction, they will meet when relatively they cover one circle. Okay, the one going from this direction, the one going from this direction, if they meet somewhere here, that means relatively they have to cover one lap. Okay, understood? So now distance you understood. Distance is equal to what? 700 meter as per this question, the length of the circular track. Now when they are running in the opposite direction, the relative speed should be 40 plus 30 because they are running in the opposite direction, speed of 1 plus speed of second. So time taken here should be distance by speed, relative speed. Okay, this will be in 10 seconds. Fine. I hope these questions are easy and clear. And yes, I am taking easy questions so that first concept should be clear. And then don't worry, I'm going to solve many questions. Okay, so this is just beginning, just to make your foundations clear. So overtake part is clear. Yeah, when it overtakes, if it is the slower one will cover x, then the faster one has to cover L plus x. L is one lap, circumference, the length of one circle, the entire circle. Okay, circumference. Okay, great. If that is clear, then we have okay, let's see this question. Let's see how do we address this question. Two runners, Umaima and Ben, on circular track, length is 800 meters, speed 10 meter per second, the slower speed is what? 8 meter per second. They both start at the same point, same time, but in the opposite direction. Okay, pause this video. Tell me the answer. How many times will they meet on the track before Umaima complete the full lap? Okay, how many times? It's not that when will they meet, how many times, number of times they meet. Pause the video, try attempting this question. I'm sure you'll be able to solve this question. So what will I do is, first of all, I'll see that Umaima, how much time Umaima takes to cover, to complete the one lap, the one full lap. Okay, So time taken by Umaima here, if I say time taken by Umaima to complete one lap should be equal to distance, the length of one lap, that is 800, divided by speed of Umaima, that is 10, right? So that should be equal to 80 seconds, right? So it will take 80 seconds for Umaima to complete one lap. Now we need to find out that in this 80 seconds, how many times will they meet? So concept of speed time distance is only this much. The formula of speed, relative speed, when distance is constant, then what happened, time is constant, then what happened, and then it's all application. So you also have to use something called brains. Yeah, so you need to use brains, and I know that my students, they are having brains. That's why you people have joined the classes, right? Okay, so in 80 seconds, how many times, if we find out how many times will they meet in 80 seconds, then our job is done. So first let's find out first after how much after how much time will they meet for the first time. Okay, and then we will say that they keep meeting after that much of time again and again, right? Because the distance is lap length is same and the relative speed will also be same. Now when they are moving in the opposite direction, they need to cover this. Do you want me to draw the diagram? Do you want me to draw the diagram? Okay, fine, you be happy. So it will look like this: circular track, 800 meters, they are moving in the opposite direction. Okay, they are running in the opposite direction, one here, yeah, Umaima and Ben, right? Now for this 800 meters track, when will they meet for the first time? So with the relative speed, they are moving in the opposite direction. Yeah, so opposite direction is supposed to be plus. So 10 plus 8, 10 plus 8. To calculate time, we are using what? Distance upon speed, right? Distance upon speed to calculate time. So the time is 44.44 seconds. Yeah. The number of time they meet cannot be in decimal. The number of time you meet anyone cannot be in decimal. Like you met your friend only 2.5 times. No, that's not possible, right? It has to be in the natural number form, correct? So hold on. Let's see how do we handle this. Now, the point what I'm trying to make here is they are going to meet, if they keep running, they are going to meet after every 44.44 seconds. After every 44.44 seconds. Let me make this number easier for you so that you will be able to understand. Let's say this is 100 and this is 60. Okay. Now let's solve this. So Umaima will take, with 100 meter per second, Umaima will take how much time to cover the lap? Okay, so I'm changing the number so that explanation or understanding of the concept will be easier for you. Umaima's speed is 100 meter per second. To cover this entire 800 meters of track, Umaima should take 8 seconds. That's the question. In the how many times will they meet on the track before Umaima complete the full lap? So Umaima is going to complete the full lap in 8 seconds. Keep this in mind. Now when they run in the opposite direction, when will they meet for the first time? So the length of the lap which they need to cover, yeah, how will it happen? Ben in this direction, Ben in this direction, okay, slower somewhere here. Umaima in this direction, somewhere over here. They will meet for the first time. So relatively together they have covered the entire lap, right? The first time they are going to meet somewhere here, which is completing 800 meters of lap relatively with the relative speed opposite direction, that is 100 plus 80. Yeah, you add the speed, sorry, 100 plus 60, we have taken 60. So they are going to meet after 5 seconds, right? 100 meters for Umaima and 60 meter per second for Ben. So they are going to meet after 5 seconds. So now if they keep running, think about it, if they keep running, this case will keep repeating, right? So they are going to meet after every 5 seconds. Now they got only 8 seconds in total. They got only 8 seconds in total. So in 8 seconds, how many times will they be able to meet? So first time, think about it, first time they will meet after 5 seconds. Yeah, first time they will meet after 5 seconds. First time they will meet after 5 seconds, right? Now second time they will meet after, from the starting point, after 10 seconds from the starting point, 5 seconds, then again continue the next 5 seconds. So 5 plus 5, 10. Are you getting it? 5 plus 5, 10. Yeah. Next time they are going to meet after another 5 seconds. So that means they are going to meet after 10 seconds. Now, total of 10 seconds. So now, in 8 seconds, Umaima is able to complete the lap. Will they get chance to meet for the second time before Umaima complete the lap? Of course not, because second time they are going to meet after 10 seconds. After 10 seconds, starting from the meet after these many seconds, from the starting point, right? You getting it? Second time they will meet after the starting point, that is 10 seconds, right? Umaima is able to complete the track in 8 seconds. Will they be able to meet in the second time? No, because Umaima will complete the lap in 8 seconds. They are going to meet second time after total of 10 seconds. They will not get chance to meet second time. So they will meet only one time. So what will be the answer in this case? The answer will be, answer is they will be able to meet only one time, okay, before Umaima complete the lap, complete the circle, complete the lap. Fine. I hope this is clear. Great. Okay. So am I applying any special formula for this? You can see I'm not applying any special formula, right? It's all relative speed and a little bit of common sense. Yeah. Okay. Next question. 3 friends are having race on the circular track. Alice is faster and jogging at the rate of 20 meters per second. Bob 14 meters per second. Charlie 12 meters per second. All right. All of them start from the same point and run in the same direction. Okay, this is given. Now we need to look at this common information and try attempting the question here, which is how long will it take for all 3 of them to meet at the starting point for the first time since they begin. Okay. Now in this case, when you talk about the starting point, meet again at the starting point, meet again at the starting point. Okay, meet again at the starting point. Please write this as a special tip. Okay, like in your note, just underline, this is important to remember. Okay, in that case, meet again at the starting point. In that case, what you do? Find the time taken by each to complete the lab. Okay, so they will complete the lab, then they will come to the starting point. Then calculate the LCM of time taken by each one of them. Why is that so? Why is that so? So think about it. If they want to meet at the starting point, think about it. If they want to meet at the starting point, in that case, suppose one example, okay, suppose if Alice is completing the lap in every 6 seconds. So Alice is reaching at the starting point at every 6 seconds. Let's say another person is Ben, let's say Bob. Okay, so Bob completing that in 9 seconds. So Bob is going to reach here after every 9 seconds. Now if you want both of them to reach together, so the time should be something which is multiple of 6 and 9, because Alice is going to be at the starting point at 6th second, then 12th second, then 18th second, after every 6 seconds. Whereas Bob is going to be at the starting point after 9th second for the first time, then 18th second on the second time. Now when he is reaching there after 18th second for the second time, Alice is also there on the 18th seconds, right? 18th seconds. So they are meeting at the starting point after 18 seconds. Yeah. Alice has covered how many laps, doesn't matter. Question is, when are they going to meet at the starting point? So this is how you should tackle the question. So I hope this is clear. So when you want them to meet at the starting point, then calculate, find the time taken by them. Find the time taken by them. Yeah. Find the time taken by each of them to complete the lap. Then calculate the LCM of time taken. That is the LCM, right? LCM, least common multiple. So you take least common multiple. Okay. Fine. Now question 840. All right. So length is 840. Now the 3 people are there. What are the name? You have Alice, Bob, and Charlie. Alice, Bob, and Charlie. So Alice, for Alice, it will be 840 meters distance with the speed of 20 meters per second. So that is going to get you what? 42 seconds, right? For Bob, when it is 840 and the speed of Bob is 14 meter per second, right? So this will be 14.56 after every 60 seconds. And for Charlie, to cover the entire lap, which is of 840 meters with a speed of 12 meter per second, that should be 70 seconds. Okay, you understood? Now if you want them to meet at the starting point again, so that should be LCM of the time which you have got here. That should be LCM of time which you got here. That should be LCM of time which you got here. Okay, so just calculate LCM of 42, 60 and 70. What will you get? Tell me, what will you get? LCM of 42, 60 and 70. That is going to be Calculate LCM. You want me to do this? Take this 42, 60, 70. Calculate this way. What will you get there? You will get 420 as the LCM. Okay, so that means they are going to meet after 420 seconds at the starting point. They will be together at the starting point again after 420 seconds. Okay, so I hope you are clear with this. Yeah, good. Did you understand the reason why are you calculating the LCM? That's very important. Why are you calculating LCM? Because Alice is going to be there on the starting point at every 42 second. So first time 42, second time 84, and then multiple of 42. Same thing for Bob, multiple of 60s. Same thing for Charlie, multiple of 70s. So we need to find out what is the common multiple of all these three numbers. Common multiple. Isn't it LCM? Least common multiple. Yeah, that's why we calculate the LCM. Okay. Another question. How long will it take for all three of them to meet for the first time since they begin? Now this time, for this question, they are not mentioning at the starting point. The difference in the second question and the first question is, in the second question, they have not mentioned at the starting point. So there is a possibility that they meet again at the starting point for the first time. There is a possibility that when they meet at the first time, when they meet for the first time, they are at the starting point. There is a possibility. Okay. So, but don't mix both of them. Yeah. When it is not about the starting point, don't look at this LCM wala part. When they are going to meet, you need to focus on this. When are they going to meet for the first time? When are they going to meet for the first time? If you see this diagram, what you see here is all of them are starting from the same point in the same direction. That's the question. Now you may see in some question opposite direction, doesn't matter. Just apply relative speed. Okay. Now in such case, when you want all three of them to meet for the first time, wherever, it doesn't matter whether they are at the starting point or somewhere in between. Okay. What you need to do is you need to take one common person. So you have Alice, you got Bob, and you have Charlie. Okay. So take one of them as common and compare the rest of two with that. For example, I take Alice common. Okay. Alice's speed is what? 20 meters per second. Bob was 14 meter per second. And Charlie was 12 meter per second, right? Let me check this again. 12 meter per second, right? Yeah. 12 meters per second. Okay. Now if I take with reference of A, and if I compare, I can't compare all three of them together, right? So first I compare A with B, then I will compare A with C. You can take some other person as the reference point. You can take C, you can take B also. Doesn't matter. But point is, take one person and then compare the other two with that. And then see when are they going to meet. So let me show you this. A and B. If I compare A and B, so A and B, when are they going to meet for the first time? Isn't it like a first question? When is A going to meet B? When A is going to overtake B? One of the same thing, right? You remember? I said this at the starting of this lecture. So, when A is going to meet B, A is going to, well, A is faster. So, A is going to meet B. That's why I either take the fastest one or the slowest one. It becomes much easier. So, let's take the fastest one right now. When is A going to meet B? A is going to meet B when A cover slower one, let's say B. So, slower one is B. When B cover X, then the faster one has to cover L plus X. Remember this? So, faster one will overtake or meet the slower one when the faster one will cover one lap extra relatively. yeah, 1 lap extra. So what is the distance, the length of 1 lap here for this case? 840 meters given in the question, 840 meters. Yeah, 840 meters. And when they are running in the same direction, then what will be the relative speed? It will be minus same direction. Yeah, so 20 minus 14. Tell me one thing, are you okay with this? In the circular track, when the faster one and slower one running in the same direction, so faster one will overtake the slower one when the faster one will have 1 extra lap. Yeah, so length of the circle. Okay, because they are running in the same direction, so speed has to be relative speed, so minus x minus y. So what are we calculating here? We are calculating time when A and B are going to meet for the first time. So here they are going to meet at the first time. For the first time, this is 840 by difference of this is 6. If you calculate this, 8 ones are, and then you got 2, 4 after 140 seconds. Okay, whereas A compared to C, you just need to compare these two. Okay, you don't have to compare B compared to C. You don't have to do that. That's not required. Why it is not required? When we are comparing A with B, A with C, and then comparing AB and AC, so the person B and person C is already covered. Let me explain this to you here. A and C are also running in the same direction. What we want to know? We want to know when are they going to meet for the first time. So how are we going to calculate? We know A is faster. So A is going to cover 1 extra lap, that is 840 meters. A compared with C, what is the relative speed running in the same direction? Relative speed will be 20 minus 12. 20 minus 12 will be 8, right? So this is 8 ones are and 8 fives are. So after 105 seconds they are going to meet. Are you getting this? Yeah. Okay. Now what do you need to calculate? When are they going to meet? All three of them are going to meet. In such case, what you do? In such case, what you do? Every 140, after every 140 seconds. A and C is going to meet after every 105 seconds. Okay, so if you take the common multiple of both of them, you will get a common number, a common time when all three of them are going to meet, right? Okay, let's see. So if I look at the LCM, if I find the LCM of 140 and 105, LCM of 140 and 105, that's going to be, take the LCM this way. Okay, that's going to be, fortunately, unfortunately, coincidentally, again you will get 420 seconds. Okay, so they are going to meet for the first time after 420 seconds. So this is a pure coincidence. It is not necessary that when they meet for the first time it has to be at the starting point. What was 420 second? 420 second was the answer, was the number when they are going to meet for the first time at the starting point. Now second question is when they are going to meet for the first time. So as I said earlier, it may be at the starting point itself. See, they are going to meet at the starting point and one fine day, one fine time, that is for sure, because everybody is completing the circle, and somewhere, sometime we will find a common multiple of the time when they complete the circle. So they are going to meet at the starting point at some point of time. But when you calculate for the first time, there is a possibility that that time may not match with the time when they meet for the first time at the starting point. Am I making sense? The previous 420 is a time when they meet for the first time at the starting point. Meet at the starting point. Here we are calculating the time when they just meet for the first time. Maybe at the starting point, may not be at the starting point, but they meet for the first time, right? So this is how you calculate. When they meet, when you want them to meet for the first time, take one person, compare to that, say compare with the second person, compare with the third person, and see when are they going to meet. You get the time and then calculate the LCM of that. Calculate the LCM of that this time, and then see what you get. This is when they are going to meet for the first time. This is when they are going to meet for the first time. Yeah, do you want me to repeat that? Yeah, this is the time when they are going to meet for the first time. Okay, and this time may be when they are going to meet for the first time at the starting point. Yeah, so both of them are different condition, both of them there is a different way to calculate. Okay, you may come up with the same answer, that's a different thing, that is calculation, but the concept is different, the method of calculating should be different. Okay, so this is it. In circular track we'll see more questions, complicated question, higher level of difficulty question in coming future. So for now this is it. My name is Shah Manawat, signing off. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.